All right, so the question is, what happens when your a value is not 1 and you need to complete the square? Because what I can see with this, and you can try on your own, it's not going to factor. So I'm not going to be able to use the approach of averaging the x-intercepts here. I'm going to have to complete the square. So you have this issue because of this value right here. Okay, so when I say complete the square, I need you to complete a square. If you tried to do this visually right now, the issue that we run into is that this is 5x squared. Okay, and we can't do, to get the sides of our square, it's going to be like 5x and 1x. That's not a square. That's a rectangle. So I can't complete the square here. So what I'm going to have to do is force it to have an x squared term that's going to be a square. So to do that, I'm going to divide everything in my equation on both sides by 5. So what that does is it gives me y over 5 equals 1x squared minus 6x plus 12 over 5. Now I'm going to leave it as a fraction. I know you guys don't love fractions, but it's probably better this way. If you really wanted to write it as a decimal, you could. I just try really hard to keep things in exact form anytime I can. So we would go through our process of completing the square. Now, if you still like to draw your picture, you can draw your picture. You know that you're going to have your x squared, which means you're going to have x and x, and you're going to split that -6 up so that half of it goes here, and half of it, whoops, that would be -3x. Half of it goes here, and half of it goes here. So what I end up with is x minus 3 and x minus 3. And then I have to figure out, how many unit tiles would I have there. So really, this is x minus 3 squared that I've come up with. Now, in this particular square, in the x minus 3 squared, I would have 9 unit tiles there, okay? The issue is I'm supposed to only have 12/5. So it's hard to sort of compare 9 to 12/5 and know exactly how much you're going to need to subtract or add on. So what might be helpful is if I think about a way that I can write, I'm going to do this off to the side here for a second, a way that I can write 9 so that it has a denominator of 5, because then it would be really easy to compare those two quantities. So if I wanted 9 to have a denominator of 5, I could write that as 45 over 5. So what I'm going to do is I'm going to replace this in my unit tile area with 45 over 5. So now here's what I know. I know that wrapped up in this quantity right here, I have 45 over 5 unit tiles. But in my original expression, I should only have 12 over 5 unit tiles. So I know that I have too many here. So I'm going to subtract 33 over 5 unit tiles? So now I have, if I were to multiply this out, I'd have 45/5. And then when I subtract 35/5, that's when I'm going to get my 12/5. So what I've done is I've rewritten my expression. But remember, it's not just y, it's y over 5, because we divided by 5 in the beginning of our process. So now what I'm going to do is I'm going to just go back through and multiply everything by 5. Now when I do that, and I'm going to multiply this side and this side by 5. Well, the left side's easy enough. I know y over 5 times 5 is just going to be y. The right side you really need to think about. When we multiply by 5, we're going to multiply this quantity by 5 and this quantity by 5. Now we can't distribute the 5 into the parentheses because we would have to square first. So what this is going to end up looking like is just 5 times x minus 3 squared. And then I multiply 33 over 5 times 5, and I get -33. This is now in graphing form. And I could identify my vertex as 3, -33. I know my axis of symmetry is going to be x equals 3. And I know it's going to open up with a stretch of 5. All right, let's try one more. All right, so this time my a value is a fraction, okay? And again, what I see is if I try to factor this, it's probably not going to factor. So using the approach to average the x-intercepts to then change it into graphing form is probably not going to work to our advantage. So I'm going to use completing the square. But once again, I need this coefficient in front of my x squared to be 1 because I need it to be a square with dimensions of x by x. So to achieve that, what I'm going to have to do first is multiply both sides by -3. All right, so what that gives me then is -3y equals. Okay, so -3 times -1/3 is going to be positive x squared, and then -6x, and then positive 15. Okay, so let's go ahead and complete the square for this. So I would create my square being x squared, so I know that I'm going to have dimensions of x by x. I'm going to put that -6x, I'm going to split it up so that it's exactly in half. I'll have -3x here. I did not mean for these to look very similar, but it's okay. So I end up with -3 and -3. So now I know my square has dimensions of x minus 3 times x minus 3, or x minus 3 squared. The key here is, again, looking at how many unit tiles are wrapped up in this expression. So I know that because my dimensions are of this piece right here are -3 times -3, there's going to be 9 unit tiles in there. So wrapped up in this expression are 9 unit tiles. But in my original expression, I needed 15. So I'm going to have to add on 6 more. I don't have enough, so I'm going to add on 6 more. So that now this expression, if I were to multiply it out, gives me exactly this. Now that's great, except in the beginning we said, well, we multiplied everything by -3. So I want to solve my equation for y. So now I've got to go through and divide everything by -3. Now, you could divide everything by -3, or you can multiply by -1/3. Either way gives you the same result, right? So if I multiply everything by -1/3, on the left side, that's going to give me y. When I multiply, again, each part of this, so x minus 3 squared times -1/3, it's going to be -1/3 times x minus 3 squared. And then -1/3 times 6 will be -2. So this is my graphing form, okay? Again, my vertex is going to be the point 3, 2. My axis of symmetry will be x equals 3. And it's going to open down, and it's going to have a compression by by 1/3. All right, hopefully this helps clear up what to do when you can't factor it and your A value is not 1.